Alright guys, in this video we want to prove the De Moivre's theorem of complex number. I want to prove that if we can have z is equals to r into cos theta plus I sin theta, therefore we can have z n r raised to the power n to cos cos n theta then plus I sin n theta. We want to prove that this is true if this can hold. Now we'll be using mathematical induction, right? Math induction to do that. So for us to use mathematical induction, that means we have to go for when n is 1. When n is 1, we have z raised to the power 1 into r raised to the power 1 cos what? Cos theta. I'm using this part here plus I sin theta. Okay, now in that case we say that this is z equals to r then cos theta plus I sin theta. Is that clear? So we have proven that for 1 we will still get our polar form. Alright, we still get our polar form. Now why not go into the next one? At this point here, we want to say assume, for mathematical induction, we do for 1, we assume that k is true, and we check for k plus 1. So assume that when n is equal to k is what? Is true. We want to assume that it's true. So we'll have something like this: z to the power of k is equal to r raised to the power k into cos k theta, plus I sin k theta. We want to assume that is true. So in assuming that is true, we want to find when n is k plus 1. And to actually do that, we can multiply z to both sides. We can multiply z to both sides. Okay? So in multiplying z to both sides, let's clear this part so you can really see what I'm doing. If I want to multiply z to both sides, I'll have in this place my z will now be equals to, this is equals to power 1, that will be k plus 1. Okay, k plus 1 is equals to, now don't forget that r raised to the power k, then we are having what? Cos k theta plus I sin k theta, right? Now what's our z? Our z is this. This is our z there. So instead of writing it, I'll just write equals to r, that is times r cos what? Cos theta plus I sin theta. In that case, z to the k plus 1, if I should bring out this one within this is raised to power 1 also. So I'll be having, in like manner, r raised to power k plus 1. Okay, so having gotten that, I will now have cos k theta plus I sin k theta, into cos theta plus I sin theta. Good. So we have already approached the k plus 1 with this method here. So what I want to do now is to open the brackets. We want to open the brackets, this bracket here and this bracket here. So we want to open it. What we need to do here is to let's clear up this part so we can have enough space. So I would have z now k plus 1. What I'm actually interested in, that I want to get to see if with k plus 1 I can also have my cos theta to have k plus 1 in front of it, just like the way we had n in front of cos theta when we have z raised to power n and r raised to power n. So that's what we are trying to drive at. So let's open the bracket here. So this one times this one here. Okay, well, multiplying, that will be cos k theta, then cos theta plus cos k theta I sine theta sine k theta, okay, cos theta, then plus I squared sine k theta sine theta. That's it there. Okay, very long, right? So let's bring it one after the other. So I have z, k plus 1 is equals to k plus 1 here. I know that I have cos k theta, cos theta plus cos k theta I sine theta plus I sine k theta cos theta, then I square is minus 1, so this will now change to what? Minus sine k theta sine theta, isn't it? So in that case I will have what? Z into k plus 1 is equals to r k plus 1. So we want to rearrange these stuffs together, so I can rearrange this to be cos k theta cos theta minus sine k theta sine theta. I just brought this one and this one together. Then I'll have again plus cos k theta I sine theta plus I sine k theta cos theta. Okay, so with that we're still going to, we need to apply the knowledge of our trigonometry. Cos A plus B is equals to what? Cos A cos B, okay, minus what? Sine A sine B. Exactly what I'm saying here. This looks like it. This is like A and this is like B. Can you see that it's interchanging here now? This is like A, this is by B. Cos sine sine. So I'm going to apply, I'm going to constrict this expression into this form. Okay, that's exactly what we're going to do to get to the next part that we want to get to. Okay, so doing that, I will have z into k plus 1 equals to r k plus 1. Now into what? Cos k theta, right, to be cos what? K theta plus theta. Now for this one also, this one looks like the one of sine. If I bring out I can come outside and I'll have what? Sine k plus k theta plus what? Theta, just from the trigonometry also. In that case, I can decide to factorize out my cos, my theta. So I'll have r k plus 1 into cos k plus 1 theta plus I sine what? K plus 1 theta. So you can see that when we have k plus 1 on r and we're having as a power of z, it actually came down to multiply the theta. So that means z to the power n, this, and when we have what? K cos n theta plus I theta is what? Is actually true. This is true. This is how to prove the Moivere theorem. So in the next video, I'm going to show you how to apply this whole thing into solving a question, a polar form question. I'm going to show you how to solve it in the next video.